teaches people to accept. Lisa Meitner said physics teaches people to accept reality with awe and admiration, not to mention the amusement and joy that comes with it. And lastly, if you're still not convinced, Einstein Rutherford said all science is either physics or stamp collecting. So people do physics. Or okay. So why physics at KAIST? KAIST physics is one of the world leaders that follows many areas of both experimental, theoretical, and technological research. And if you know that KAIST has an extensive focus on research and practical work that helps you whether you join an academic career or industrial career because you will have a lot of research experience. Next, I have to talk about job, grad school, and internship opportunities. Basically, what you can do with your BS in physics degree. So the cool thing about physics is, in a physics degree, you learn a lot of different areas. For example, you learn a lot of math, a lot of computer science. Many you do various practical works and some theoretical works. What it gives you unique set of problem solving skills, no matter what unrelated areas that might be, that skills and that thinking capacity will always help you. For example, um, do you know the www dot that World Wide Web? That thing was created by CERN physicists. And recently, for the COVID-19 situation, many epidemiological models. One of those models is created by a physicist who was a theoretical physics major. He did his PhD in theoretical physics, then he shifted to epidemiology. So that's the core message I have to send. If you do physics, your skills that you get that will help you in all the areas. Mostly physics graduates will go and join a grad school. If you want to do industry jobs, usually people do a master's, and your thesis lab should be relevant to the industry. And if you want to do a research or academic pathway, usually you do a PhD and then if you postdocs. And regarding internships, you can join summer internships after your second or third year when you have a grasp on most things in physics. And also in KAIST, you can always ask a professor to take you for an individual study. Next, I want to talk about the academic environment, and I subtitled this thing about trust me, we're better than general physics. Everyone has to take 2 general physics courses, and they actually kill you all the love for physics. But trust me, in the major courses, it's much better. Firstly, the class size is small. Physics is a small department, so depending on the course, you will have 10 to 40 students in a class, and the professors and TAs, they are much more enthusiastic in teaching and in course contents. If you check our course contents, they're all world class. If you check that with other available course materials online. But the thing is, physics everywhere in the world is notoriously hard, and at some moment you feel so hopeless, and then only the love of physics will keep you going. In KAIST, we regularly have seminars from researchers from KAIST, other universities in Korea and the world. They talk about their works, and we often have get-together events department-wide. But the thing is, the last point I'm guessing from the website and past photos, because when I joined physics, the pandemic already started. So next, assignment and exams. It's kind of similar to other departments. Usually the courses will give you problem set twice every 2 weeks. So total 6 or 8 problems sets per semester, and they will account usually about 30% of your course percentage. Sometimes some courses have problem sets every week, and just like general physics labs, the labs will usually have one experiment per week that you have to submit in report. And apart from traditional closed book exams, I found many courses that offer open book exams, but that usually means that the courses are very hard. And some courses might have assignment-based midterm or finals too. For example, if you take computational physics course, it has a final project or something. I will talk about these details when you ask questions. So about the difficulty of physics. So Arnold Sommerfeld, he said thermodynamics is a fun subject. The first time you go through it, you don't understand it all. The second time you go through it, you think you understand it, except for 1 or 2 points. The third time you go through it, you know you don't understand it, but by that time you're so used to the subject, it doesn't bother you anymore. Okay. And Richard Feynman, in one of his books about physics, he said, "What I am going to tell you about is what we teach our physics students in third or fourth year of graduate school. It's my task to convince you not to turn away because you don't understand it. You see, my physics students don't understand it. That is because I don't understand it. Nobody does. So many areas of physics are like that. We just do stuff. Okay. So finally, I guess the largest part of my presentation, labs and courses. So I'll try to introduce the labs and courses that you can get in physics department, and feel free to ask questions about these because it's very important. Okay. So the physics department has mostly 4 areas of research. So we can call it sub-departments. So the largest is condensed matter physics. They do all sorts of theory and experimental research in spin systems, nanomaterials, magnetism, low temperature physics, superconductors, crystal, almost all areas of condensed matter physics. Then the second largest department is optics. They do various theoretical and experimental research in light matter interaction, lasers, quantum optics, quantum information, and some quantum computing and nanophotonics, things like that. Then a smaller sub-department is high energy physics. They usually do quantum field theory and string theory, theoretical and experimental particle physics, and some astroparticle physics in cooperation with IBS, Institute of Basic Research, that's uh, situated in our campus. And finally, there is complex system and biophysics. They do statistical physics, complex systems, nonlinear dynamics, biosensors, biomedical optics, biophysics, and some structural biology. And one of the labs, they also do the modeling of economics and stuff. So next, so the how the KAIS department curriculum is planned. They expect you to learn some basic math courses, for example, linear algebra, differential equation, and there is a general physics lab 2 that is required for physics majors. So they expect that to be learned in first year. In the second year, mechanics, electromagnetism, modern physics, mathematical methods, and lab. Third year, quantum mechanics, optics, thermodynamics, and some other courses. And in fourth year, you do the third lab, thesis, and some advanced courses. But the problem is, this is designed for spring entry. And if you did not plan to join physics courses already, so this can be a bit troubling. So here I have shown a possible course plan, and this is not like exclusive because it depends on how you want to plan things. For example, I put general physics lab 2, assuming you haven't taken any courses towards your physics major yet. So in the fall semester, upcoming fall semester, you should take general physics lab 2, differential equation, linear algebra, applied analysis, or probability studies. Those are all math courses. So you should learn a lot of math in the upcoming semester because you will have to use those in your physics courses. Usually the physics inside the physics courses, they will teach you those in short, but you will suffer a lot if you don't already have vast knowledge. Then in the next spring, you can take classical mechanics 1, electromagnetism 1, and modern physics, which is now in English. And then in the fall, the second part of electromagnetism and classical mechanics, along with mathematical methods in physics. This is one of the hardest courses I have yet taken. And in the next spring, quantum mechanics, thermal physics, mathematical methods, part 2 and lab. So this lab is very hard and very time consuming. So I talked with Ada and she said, this just forces people to change majors. So just make sure that when you are taking the lab course, you're prepared. mentally. Then in the fall, you can take quantum mechanics 2, statistical mechanics, and optics. And I have noted thesis here, but you can like swap this around. For example, you can take the thesis in your last semester and take lab 3 in the semester before. It depends on you because there are some course numbers that refers to the which year you should take those. For example, 300 level courses for third year, but you don't necessarily have to follow that because it depends on you. But sometimes the courses would have some prerequisites if you visit the syllabus. For example, if you want to take quantum mechanics, you need to learn some linear algebra. And if you want to take statistical mechanics, you need to learn thermal physics. So just look at those prerequisites and see and make a course plan of your own. This is just a guide. And for example, if you want to rather do a more practical lab, so for example, if you want to do experimental physics or technological side later, you might take lab 2. Lab 2 is sometimes offered, and maybe you can drop general relativity. And if you want to take more theoretical approach, you could take more math courses from math department, things like that. And in summary, it depends on you, but just check that you know the prerequisites before you take the course. Okay, and there in the next slide, I want to talk about the popular department combinations. I am doing an advanced major in physics. That means I'm only taking physics courses throughout my bachelor's degree, but you don't have to do that. You can take another minor course, or you can do a double major. So these are the most popular combinations, especially the people who want to do theoretical physics later. They tend to take a math minor or double major because there are many math courses that can help you to rigorously understand physics. For example, there's a differential geometry course in math department. If you take that, you will understand general relativity better, things like that. So they're really compatible if you want to do theoretical physics. And if you want to do applied research later, E is a very popular choice because many optics and quantum matter based research, for example, semiconductor physics, those things they overlap often. So if you take a E minor or double major, then it can help you a lot because in E you have more practical applications than physics. So these two go hand in hand. And thirdly, if you want to do simulation or modeling tech research later, for example, if you remember in the research tab, um, the fourth thing like complex system and biophysics, if you have a good computational capabilities, then it may help you in those research. And especially in all of areas of physics research right now, you need to have good competency in computers, in computational languages and simulation. So this is another choice. And recently I have met a lot of physics undergrads who are also doing this, CS along with it. So this is kind of it. And finally, if you're still not convinced, there's another quote from someone you might know. So he said, why suffer alone when we can suffer together? So just join me in physics department and we can suffer together. Okay. So that kind of ends my presentation. If you have any question, please ask her.
All right. So, Akib, are you done?
Yes. So I can take questions now.
Okay, so there aren't many questions, so we can just get started with the Q&A session then. So I'll just read them out in order.
Okay.
Those questions that are relevant, of course. Um, so the first question is, should one do experiments if they want to be a theoretician?
Okay. So in physics major, if you have to take 3 labs. So general physics lab 2, that's required. That's one credit course. Then lab 1 and lab 3. So you have to take those courses for the physics major. And sometimes like this is ideas of those people who want to go to theoretical physics that you don't have to do lab, but lab courses, they force you to be humble, because then you know that things might not go as you plan. So that experience is very important, I think. So do your lab courses properly. If you still like promise to never touch equipments again, still do your lab courses properly.
Okay. So there's another question. Which physics courses are in the first year?
Okay, so in the major courses, all of those are in starting from 200 level. That means they're second year courses. So the kind of the first course you take in physics department, those are classical mechanics and electromagnetism along with modern physics. So I planned it that way in this slide, as you can see. And all of those are offered in spring. So if you want to take physics major and haven't taken any of those courses, which is like which should be the normal, because you will not take those courses in first year, then you should now in the next semester you should take the required math courses now, and then you can take in the spring classical mechanics, electromagnetism, and modern physics. And if you like any other courses that you think you can cope with, then take it.
Okay, so let's move on to the next question. Can one do a course that is, for example, for third year in the fourth year?
Yes, it's completely fine. You can take whatever courses whenever you want. That's the problem. For example, if you can see here, I have noted lab 1 in your end of your third year, but it's actually noted as 200 level course. The thing is, the course numbers 200, 400, 300, those doesn't matter a lot. You can take whenever you want. Just make sure that you have the prerequisites, otherwise you'll suffer.
Okay, so there's a research-related question next. How early should a student try to get involved in research?
Sorry, could you?
Oh yeah. How early should a student try to get involved in research?
Okay, it actually depends on you. For example, a lot of labs, they do not require a lot of prerequisites. For example, if you want to do simulation type works, if you have enough computational capability, you can just do that. But for example, you want to do statistical, if you want to do solid state physics lab, then you would expect to already have taken the solid state physics course. So it depends on what courses you want to take and what lab you want to join. But I guess if you are not sure, just email the professor in the lab and say that you have taken these and these courses. Also, what you can do is go to the lab website and you can check their papers. Just go through the papers and see if those make sense. If it kind of makes sense, I guess you can do that. Yeah. But most people actually do their research in end of third year and fourth year. So those are the like average most probable times. But you can, if you are capable enough, if you have already have the prerequisites, you can do those as early as second year. That's up to you.
Okay, so what opportunities does one have in their undergraduate years to build up a profile for theoretical physics? Any publishing that would help or anything else?
If you want to do if you have to do theoretical physics in say for your life, you have to join grad school and stuff. So yeah, publishing will always help to join grad school. And there are some theoretical physics labs. I mean groups who work in theoretical physics. For example, I'll go here. So in condensed physics and optics, they do theoretical physics, and in high energy physics, there are also other theoretical physics people. So you can contact them and like ask for suggestions what courses you should take, or when you can like do theoretical physics with them or something, like for suggestions. And But usually what happens is theoretical physics is kind of like very advanced compared to the experimental physics, because in experiments you have to and the setup and stuff. So theoretical physics people, they are with their math ability, they are way first. So you have to acquire a lot of background knowledge to do a very impactful theoretical physics research. So I guess you should talk to the lab you want to do it into theoretical physics. So they can provide you the best solution of how to approach those research.
Okay, so there's another question. I don't know if it's relevant or not. So if we cannot make a breakthrough, is it still okay to continue research?
Yes, like if you most people do not get any breakthroughs. I mean, breakthrough as in newsworthy things, but still, they're always we are always like we as in people are always pushing the limits of our knowledge every day. So that is not a huge problem. If you love physics, the not do just learning about it, it's immense joy too. If you don't make it break.
Okay, so is it possible to take the basic required general physics courses and labs afterwards?
It's possible. And actually, as Ada said, she suggested you take the labs later, but I would say you should just take the general physics courses as soon as possible. Just get over it, because they will kill all the love you have for physics. So just bury it on the way and move on.
Okay, so yeah, I think that's all for the relevant questions. For the question that asks whether students generally go to MIT, Berkeley, or Stanford, I think you should visit our Kai Talks alumni talk session, episode 2, so you can get to know more about this.
And just another thing, if you visit the faculty list of physics department, you will see a lot of faculties are they did their bachelor's in KAIST and then did their masters in the top schools in US. So that I would guess it's possible. But again, it's very subjective. It depends on you.
So yeah, as of now, there are no more questions. No questions from Terence Tao here either. So I think we can just end the session if there are no more questions.
There is a
Yeah, sure,
comment from
Ada.
Ida.
Yeah, sure.
Oh, yeah. So for people who don't know, I'm currently 8th semester physics as well. And I think Istiak gave a great introduction as someone who is very enthusiastic about physics. But I wanted to give kind of a, my experience in physics has also been that obviously there's not very many international students in the department, and it's a pretty small department. So you kind of need to have a lot of self-motivation to do physics. But yeah, I think good luck to anyone who is interested in physics, because it's not easy, but it can be very rewarding.
Okay, so there is a question from Terence Dow. How can I change my character physics if I'm already 40 plus? I guess it's possible, because I can name two people. First, first is Edward Wheaton, if you know him. So he's one of the like living legends of our time. So Edward Wheaton had his bachelor's in history, I think. Then he did economics and English, I think. Then he chose math and then physics. So I guess so. So I think when he started doing physics, he was already over 30. So you can do, and there's another example. So that's from theoretical side. From experimental side, Edwin Hubble, who like found the Hubble constant and stuff. So Edwin Hubble's undergrad was in, I think, law. He had a law degree, and then he chose physics. So yeah, it's never like. Okay, so why there is no Nobel Prize in math? Because Nobel Prize is only offered to the things that matters. The mathematicians are there just to like do the tough job for us. Okay.
That's the best answer I've heard today. So I think we can stop rolling since there are no more questions. So everyone, thank you for joining, and Akib, thank you for a wonderful introduction to the lab. I think seeing your enthusiasm, many people can be convinced too. So yeah, everyone, this meeting is being recorded and might be shared on our Facebook page. So keep a check, and thank you for joining.